Lifting belt. A lifting belt doesn't actually support your back. That's the most common misunderstanding about it. What the belt does is give your core something to push against. When you take a deep breath into your belly and brace, your abdomen expands outward. The belt creates a wall around that expansion which spikes intra-abdominal pressure and completely locks your core in place. That's what stabilizes your spine under heavy load. It's all about creating that internal pressure, and that's why a belt feels useless when you wear it casually but completely different the moment you brace correctly. Position it around your waistline, not down on your hips. That's where the diaphragm pushes when you breathe in. If it's sitting on your hips, you've got a fashion accessory. It's also not a beginner tool. Strap a belt on someone who hasn't learned to brace and they just rely on the belt instead of developing the pattern. Learn to squat and deadlift unbelted, up to a weight on the bar equal to your own body weight first. 3 closure types dominate. Prong belts use a buckle, cheap and durable but slow between sets. Lever belts pop open in a second, which is why competitive powerlifters use them, but you need a screwdriver to resize. Velcro is quick but loses stiffness over time. There are also tapered belts that are wider at the back and narrower at the front, comfortable but with less bracing surface than straight belts. Thickness comes in 10 and 13 millimeters. Width is typically 10 centimeters all the way around. Leather is the standard for serious lifting because it stays stiff for decades. Nylon is softer and lighter, fine for bodybuilding work where maximum bracing isn't the point. If you compete, IPF rules cap belts at 10 centimeters wide and 13 millimeters thick. Bring anything bigger and you'll be sent back to your bag. Lifting gloves. Lifting gloves are one of the few pieces of gym equipment that actively work against you on most lifts. The pitch is reasonable. Padding protects your palms from knurling, your hands stay smooth and no calluses. Calluses get a bad reputation, but they're a useful adaptation. Your skin becomes the part of you that grips a bar best. Lifters who train barehanded long enough develop hands that lock onto a bar in a way gloved hands literally cannot. Verdict is personal preference, but almost no serious powerlifter, weightlifter, or strongman wears gloves. The stronger people get, the more grip feedback matters. If you train light, gloves are fine. If you want to actually move heavy weight, they're slowing you down. Chalk. Chalk doesn't make your grip stronger, it just makes your grip drier. That distinction sounds small, but it changes how you use it. Sweat reduces friction between your hand and the bar, especially during high-rep sets or in a humid gym. Chalk absorbs the moisture and brings the friction back to where your grip can do its job. Your grip strength is the same, the bar just stops betraying you. Lifting chalk is magnesium carbonate, which is different from the calcium carbonate chalk used in classrooms. Classroom chalk doesn't absorb moisture, so it does very little for grip. If a bar smells faintly like a school supply closet, someone tried. A light coat across the palms and fingers is enough. Caking it on does nothing extra. The more common mistake is rubbing chalk directly onto the bar, which fills the knurling with white paste and turns the rough surface smooth. The whole point of knurling is to grip your skin. Filling it in defeats it. 3 formats. Block chalk lasts longest and is the gym standard. Loose powder is faster to apply but messier and usually banned in commercial gyms. Liquid chalk dries on like glue, leaves no dust, and is the only version most gyms allow. If your gym is one of the no chalk gyms, liquid is your only path in. Straps. Straps remove your grip from the equation. That's the entire point. When you do a heavy back row or a lat pull down, your forearms and grip almost always fatigue before your back does. Without straps, you stop the set when your hands quit, not when your back has actually been pushed. Straps wrap around the bar and your wrist so the load hangs off your skeleton instead of your fingers, and the target muscle gets pushed past where your grip would have stopped you. The trade-off is real. Grip strength only develops from being used. Use straps when bypassing grip is the point. Leave them off when grip is the point. Wrapping a lasso strap is easy to get wrong on the first try. The strap goes around your wrist with the tail hanging down. You feed the tail under and around the bar so it spirals away from your body. Then you grip the bar and roll your wrist forward to tighten. If you do it backward, the strap unspools mid-rep. 4 common types. Lasso straps are the standard, easy to release, work for almost any pulling movement. Closed loop or Olympic straps form a fixed loop you slide your hand into. Built for snatches and cleans because they pop free instantly if you have to bail on the lift. Figure 8 straps lock your hand to the bar with no slip at all, which is what strongmen and heavy deadlifters use. Lifting hooks replace the strap with a metal hook that catches the bar. Fastest setup, no bar feel at all. CrossFit uses gymnastics grips on pull-up bars on the same logic. Pick your strap based on the lift. Don't pick your lift based on what your straps can do. Wrist wraps. Wrist wraps and straps are completely different tools. Straps attach you to a bar so your grip can rest. Wraps stiffen your wrist joint so it can't bend backward under load. One is for pulling, the other is for pressing. When a heavy bar sits on top of your palm during a bench press or overhead press, the wrist wants to fold backward. A wrap stiffens the joint to keep the bones stacked under the bar instead of behind it. The press feels more direct, and you stop losing power into a bent wrist. The most useful applications are bench press, overhead press, and heavy front squats where the bar sits on the front of the shoulders and the hands tip backward forward to support it. The wrap belongs high on the wrist, right at the joint, so it stiffens the actual hinge. Wrap too far down the forearm and you've got a snug forearm sleeve that does nothing for the wrist. The thumb loop is for setup. You hook it around your thumb to anchor the wrap while you spiral it on. Then many lifters slide it off before the lift, since leaving it on can pull the wrap out of position. Both keeping it on and tucking it work, but tucking is more common in powerlifting. Wraps come in stiff powerlifting versions and softer flexible versions. Stiff is heavy-duty cotton with thick elastic, miserable for moderate weight but excellent under maximal loads. Flexible wraps are lighter and better for general training. Lengths run 18, 24, and 36 inches. Longer means more layers, which means more stiffness. If your wrists hurt every session, wraps are not the answer. They're a tool for heavy work, not a fix for a joint that needs attention. Knee support. Knee sleeves and knee wraps look like they belong in the same category. They don't. They do opposite things and they're built for opposite goals. Knee sleeves are tubes of neoprene you pull onto your leg before squatting. The job is compression and warmth. Compression squeezes the joint and increases proprioception, which is your awareness of where the joint is in space. Warmth keeps the synovial fluid moving, which helps the joint feel ready to load. What sleeves do not do is provide structural support. They aren't holding your knee in place, they're just making it feel better while you load it. Thickness is usually 5 or 7 millimeters neoprene. Thinner moves more freely, fine for general training. 7 millimeters is stiffer, retains more heat, and feels snug under maximal squats. IPF competition rules cap sleeves at 7 millimeters. Knee wraps are a different animal. Long strips of elastic fabric, often 2 to 2.5 meters, wrap tightly around the knee in an X pattern before a heavy squat. Wrapped right, they store elastic energy at the bottom of the squat and release it on the way up, like a slingshot. A serious wrap job can add a meaningful amount of weight to a max squat, especially out of the hole. Wraps are equipped powerlifting territory. They take time to put on, they're uncomfortable, and they're not for casual sessions. Federations that allow them treat the wrap lifts as a separate category from raw lifting because the carryover is that significant. Sleeves are warmth and joint feel. Wraps are performance equipment. Elbow support. The elbow setup mirrors the knee setup almost exactly. Two tools, opposite jobs, same logic. Sleeves for compression and warmth, wraps for elastic carryover on a maximal lift. When it comes to elbow sleeves, once you start training heavy presses regularly, elbow tendons take a beating, and warmth genuinely helps. Same 5 and 7 millimeters options. The movements that benefit are heavy bench press, overhead press, and tricep isolation exercises. For lighter pressing or anything pulling, sleeves are unnecessary. Elbow wraps are the equipped version. Same elastic fabric and X pattern as knee wraps, but smaller, applied to support the bench press at the bottom. They store force during the descent and release it on the press out, which can add a noticeable amount to a max bench. Equipped powerlifting territory, not casual gym sessions. If you press heavy 3 or more times a week and you've started feeling a low-grade ache around the elbow, sleeves are worth trying before that ache becomes chronic tendinitis. They aren't fixing anything by themselves, but they buy you a lot of comfortable training time you wouldn't otherwise get. Slingshot. The slingshot is a thick rubber band you wear around both elbows during the bench press. And yes, that sentence is the entire device. It was created by Mark Bell, a powerlifter who realized the bottom of a bench press is the weakest point of the lift. The bar leaves your chest with the most leverage against you, and once it's a few inches up, the press gets easier all the way to lock out. The slingshot solves the bottom by storing elastic tension when the bar touches your chest, then releasing it as you press up. You can hold a heavier weight than you'd ever bench raw, and the top half of the press has to deal with the overload. That's the overload principle in equipment form. Train regularly with weight you couldn't lift unassisted, and your nervous system gets used to handling it. Take the slingshot off, the heavier weight starts feeling familiar. It's also useful for high-rep pump work, dealing with shoulder pain on bench day, or pressing more total volume on weeks where joints are cranky. Not legal in any competition. Pure training tool, used in the gym, left in the bag on meet day. Training footwear. People treat footwear as an afterthought and then wonder why their squat keeps shifting around or their deadlift feels heavier than it should. Running shoes are the worst case. The whole design is built around an air or foam pocket that compresses to absorb impact. Good for running. Under a heavy squat, that compressing sole stores energy unevenly, the load shifts side to side as the foam squishes, and any power you push into the floor gets eaten by the cushion and the squat then feels like balancing on a couch. Flat-soled shoes solve most of that. Converse and Vans are the classic choices because the soles are basically rubber slabs that don't squish. Cheap, durable, available everywhere, and they work for almost everything. Plenty of lifters never need anything else. Weightlifting shoes are a different category. The defining feature is a hard, rigid heel between roughly 0.6 and 1 inch tall, attached to a sole that doesn't compress at all. The raised heel changes the geometry of the squat. With your heel higher than your toes, your shin can travel further forward over the ankle, your knees can track further out, and your torso stays more upright. For high bar squats, front squats, and Olympic lifts, that's the difference between hitting depth comfortably quickly and grinding through every rep. The trade-off is that the same heel actively hurts your deadlift. Deadlifting is all about being as close to the bar as possible, and a heel raises the starting position, which means more total distance to pull. Wrong tool for that lift. Deadlift slippers go the other direction. The thinnest possible sole, sometimes a few millimeters of rubber, with maximum floor contact and minimum height. Shorter range of motion, more stability, and you can really plant the heels. Lifters typically pair them with deadlift socks, which keep the bar from dragging up your shins and bleeding all over the platform. Most federations allow them. If you don't want to commit to a pair of weightlifting shoes, a squat wedge does most of the same work. A small angled platform you put your heels on during squats. Same mechanical effect as raised heels. Some gyms may have it, but it's available for under $20. And a useful test for whether heel elevation actually helps your squat before dropping serious money on shoes. Dip belt. A dip belt is a belt with a chain hanging from it that you clip a plate or kettlebell to, so the weight hangs between your legs while you do bodyweight movements. While it's called a dip belt, it's also used for pull-ups and chin-ups. Bodyweight movements have a problem. The first time you do a dip, it's hard. By the time you can do 20 to 30, it's not really stimulating anymore, it's mostly cardio. To keep the progressive overload, you'd want to add load somehow, and a dip belt is the cleanest way to do it. Weighted dips, pull-ups, and chin-ups all become long-term progressive movements once you can load them. A trainee who could barely manage 3 pull-ups a year ago can be hanging 20 or 30 kilos off a belt for sets of 6 in not much time, and the upper back development from that pattern is hard to replicate with anything else. Loading is straightforward. The chain runs through the plate hangs at chain length below you, and you adjust so the weight isn't hitting the floor at the bottom of a dip or banging your legs at the top of a chin-up. Cable cuffs. Cable cuffs are exploding in popularity right now, and the reason is simple. They take grip and the limbs you don't want involved out of the lift completely, so the muscle you're trying to train has nowhere to hide. The logic works for any cable movement. 3 forms, each strapping a different body part directly to the cable. Ankle cuffs wrap around the ankle with a Velcro closure and a D-ring that clips to a low pulley. Cable kickbacks for the glutes, cable hip abductions, cable leg curls, and cable leg extensions. Wrist cuffs do the same for the upper body. Lateral raises become a movement where the side delt is purely lifting the cable, and your forearm and grip aren't burning out before the side delt fatigues. Tricep pushdowns work the same way. The arm becomes a lever, with no grip involvement at all. Elbow cuffs go a step further. They strap around the forearm or right above the elbow, so on a lat pull down, the cable is pulling on your elbow, not your hand. The biceps are completely out of the movement because there's no grip and nothing to flex through the elbow. The lats have to do all of it. This is the trend that the gym goers have been on for the last few years, and it's still there. The biceps aren't supposed to do the back's job, and the forearms aren't supposed to limit your shoulder work. Cuffs make sure they don't. Whichever body part is strapped in, the principle is identical. Take out the weak link, force the target muscle to handle the entire load, and the muscle you wanted to train actually trains. Arm blaster. The arm blaster is a curved aluminum or steel plate worn against the front of the torso, held in place by a strap around the neck with 2 slots that lock your elbows in position. Standing curls become preacher curls without the bench. The point is to eliminate elbow drift. When the elbows aren't pinned, they tend to creep forward as the weight gets heavier, which lets the front delts and traps share the load and cheat the movement. The arm blaster pins them against the plate and forces the biceps to do the entire job. Strict reps become unavoidable. It's an old school bodybuilding tool, popular in the Arnold era, niche now. Drop set pin. A drop set pin solves a problem for anyone who's done drop sets on a weight stack machine. The point of a drop set is to strip weight without resting, keep the muscle under load, and push past the point you'd normally stop at. Doing that on a weight stack cable machine traditionally means yanking the pin out mid-set, fumbling for the lighter slot, sliding it in, and hoping you didn't lose 5 seconds of pump in the process. With a partner, manageable. Alone, awkward. The drop set pin is spring-loaded and lets you preset both weights at once. You insert the drop set pin at the heavier weight, the one you start the set with, and a regular pin at the lighter weight above it. You start the set heavy, and the moment the stack touches down, at the eccentric part of a rep, the spring mechanism ejects the drop set pin, and the load drops automatically to the lighter pin. You keep going without breaking rhythm. It only works on pin-loaded machines, since there's nothing to insert it into on free weights or plate-loaded equipment. Barbell pad. A barbell pad is a foam tube that wraps around the bar to cushion whatever's pressing into it. There's a debate about it, and the answer depends on the lift. For hip thrusts, the pad is doing real work. The bar sits directly on the front of your hips, against soft tissue and pelvic bone, and once you're loading anything respectable, the bar bites into that area in a way that distracts you from the actual lift. The pad solves it without changing the mechanics, pure comfort, no compromise. For squats, the math goes the other way. A high bar squat already wants the bar tight against your traps, and adding a pad raises the bar position, makes it less stable, and softens your contact. Serious squatters skip the pad and let their traps adapt.